Problem 2 is a Regent's favorite, and it usually shows up on every single one. It says a triangle is dilated by a scale factor of 3 with the center of dilation at the origin. Which statement must be true? And they're going to be talking about several things about the triangles. The first one talks about the area, second one talks about the perimeter, then it's talking about slope, and then the measure of each angle. And for this one, I would go case by case and just test it out. And it says, we'll look at the bottom. We'll actually work our way up. If we look at D, it says the measure of each angle in the image is 3 times the measure of the corresponding angle in the original. So I'm going to draw an original, and I'm going to make a nice right triangle because that's an easy one to remember. And I like a good old 3, 4, 5 right triangle. And if we were to dilate that, if I were to copy, paste that thing, let's color it blue, boom, and if I were to dilate it, you can see that the angles are not changing. That is still a 90-degree angle. It didn't become 90 times 3. So that's how I know that whole entire talking about the angles getting multiplied 3 times the measure, that can't be correct. Any transformation will preserve angle measure. It's going to preserve shape. Dilations only change the size of sides. And if we keep on going to C, it says the slope of any side in the image is 3 times the slope of the corresponding side in the original. And that's also not true, because another feature of dilated figures is that they're parallel. So if my original side, that hypotenuse here, and I'll color it in green, this hypotenuse, it's going to get dilated to be that new hypotenuse. And if you look at them, they're going to be parallel. So if things are parallel, then their slopes need to be equal. And that's how I can tell you that C is not true, because that slope didn't increase 3 times. It didn't get steeper. It stayed the same. So that's how I know C is incorrect. Let's do this. Let's erase those dimensions. Let's look at the perimeter now. And you should just make up some numbers. I know a 3, 4, 5 triangle is certainly true. That's something that exists. And when I go to dilate it by a scale factor of 3, each side is going to get multiplied by 3. So this side will be 3 times 3, which is 9. This side will be 4 times 3, which is 12. And my hypotenuse will be 5 times 3, which is 15. Okay. And it's saying the perimeter of the image is 9 times the size of the original. Well, perimeter equals just sum of all sides. Just add the sides, all right? That's like a plus. So the perimeter of my original would be 3 plus 4 plus 5. That's 7 plus 5, that's 12. So the perimeter is 12. And what they're making the claim is that this perimeter should be my original times 9. And I'm going to test that out. I'm going to say, okay, my original perimeter of 12 times 9. They're making the claim that this perimeter should be 108. And I can just test that. I can actually add all 3 of my sides. I can do 12 plus 9 plus 15. And you can see that's not true. 108 does not equal 36. All right, that the perimeter does not grow by a factor of 9. It actually grows by a scale factor of 3. If we were to take our original perimeter of 12 and multiply it by 3, we're going to get 36, which is exactly what we get when we add up all those dilated sides. And so it's not B. It doesn't grow by the scale factor of squared. It didn't grow by 3 squared, which is where they're getting that 9 from. And that only leaves one answer, answer choice A. And even if you weren't able to recall that fact from our unit on dilations and similarity, you could still test it out. You could literally calculate the area of both triangles, because the area of a triangle triangle area equals 1/2 base times height. So the area of this original is going to be my base of 3 times my height of 4, then cut in half. So that area equals 3 times 4 times 1/2. That would equal 12 times 1/2. That's going to equal 6. So the area equals 6. Here, in the new triangle, my area would be 9 times 12 times 1/2. 1/2 of 12 is 6, so that's 9 times 6. 9 times 6 is 54. So my area will be 54. And I can test out this idea that it's going to be the original area times 9. So my original area was 6, and if I multiply that by 9, boom, you can see that is what we get for the new area, thus verifying that when you do a dilation, the area doesn't get multiplied by the scale factor, it gets multiplied by the scale factor squared. And that's because your scale factor is showing up in the base one time, and it's showing up in the height another time. So your area, your original area, 3 times 4, it's not just getting multiplied by 3 one time, it's getting multiplied by 3 2 times, 3 squared. And that's where they're getting it grows by a scale factor of 9.